This is the second question that appears on the summative assessment 9.3. This is the formative, of course, right? And it's always got a cable or something like that, right? That acts in the x direction a little bit and in the y direction. Okay, so what we've got is we've got this guy here. So hard to draw diagonal lines like that, right? So I'll call that T, right? And of course T has a mighty component here and a mighty component there, right? Okay, so that component there is T cos theta, right? And theta is 52 degrees, so that's T cos 52, and it's to the left. Notice that, okay? It's pulling that part of it, right? And then this is T sine 52. That's what this guy is here, okay? So basically we want to break that guy into components. And then we've got, we'll guess that the wall is in the y direction here. So we've got wall in the y direction, and then we've got wall pushing in the x direction, right? Okay. Then we've got the weight of the beam. So we've got 16 G at, let's see, it's 6.2 meters long, the beam is, right? It's uniform, so the center of gravity is at the center of the beam, right? So the 16 G is going to be at 3.1 because that's the center. And the G is not grams, that's 9.81. That's what I mean by that, right? And then, of course, the force of gravity of this guy is going to be down here. Okay, so we got 12G at, how far is it? Let's see, 0.7 meters from the right side. So this is like higher math, right? If it's 0.7 from the right side, that means it's 6.2 minus 0.7, which is 5.5 from the left side. Okay, so all of these distances are from the left side. Let's see. The cable is 2 meters from the left side. So this is at 2 meters, right? And I'll always set these up so you can always torque them about the left side. Okay, so here are our forces, right? We got the wall in the y direction. We've got the wall in the x direction. We've got the cable, which is pushing up at an angle. So there's T cos theta toward the wall, T sine theta lifting up, right? And then we've got the weight of the beam, which is 16 times 9.8, and that's at the center of the beam. So the beam is 6.2 meters long. So that would be at 3.1. That's half of 6.2, right? And then the 12 times 9.81, the weight of this box, or whatever it is, right, is at, it's 0.7 from the right side. So that's 6.2 minus 0.7 is 5.5, right? Okay, so now let's set up our mighty x equation, okay? So we've got positive wall in the x direction minus T cos 52 is 0. Can't be solved because we don't know this and we don't know this. So what'll happen is we'll solve for T and plug it in, right? I forgot the S for cos. All right. All right. In the y direction, I've got let's see, wall in the y direction. Plus T sine 52 minus 16 times 9.8 minus 12 times 9.8, and then that's it. Right, so remember in the y direction, all we really care about is just, is it up or is it down? Okay, plus is up. These guys are up, right? The wall, we're guessing that the wall is up, right? Okay. Could be that the wall's down though, right? Because it's holding it up really close to there. So it might be that this has to push down. We'll find out whether that's positive or negative here. Okay. And then we've got the part of the force of the cable is acting up. Gravity of the beam is down. Gravity of the sine is down. Okay. And we can't solve this one either. We don't know that, and we don't know that. Okay. So let's set up our torque expression. For torque, partition this off, right? Let's torque about the left side, right? About the left side. So we've got 0 times the wall in the y direction. Notice I don't even worry about the wall in the x direction because it's acting along the beam. So it's 0. That torque is 0 for 2 reasons. One, the angle is 0, and it's always r times f times the sine of the angle, right? And the sine of 0 is 0. And it's also 0 because it's acting at the pivot point, right? In fact, sometimes people don't even write that term in there. Okay, and then we've got anti-clockwise. The cable is going to tend to torque that thing anti-clockwise. So minus 2 meters is where the cable is attached, right? Times t sine theta, so sine 52. Okay, and then this is going to be a positive torque about that point there, right? If that were the only force acting, it would make it spin like a clock. It would go clockwise. All right, so plus 3.1 times 12 times 9, whoops, 16, sorry. It's 16 times 9.8. Right, and now we get out to this guy, so plus 5.5 times 12 times 9.8. So that's a 16 right there. All right. Okay, so I think we got all our torques. That's going to add up to 0 as well. Okay, so we've got the wall, which is at the pivot point, so there's no torque. We've got the cable torquing anti-clockwise, right? We've got the weight of the beam torquing clockwise, the weight of the sine torquing clockwise, and all right. And this, because of our strategery here, this is solvable for t. All right, so let's solve that for t. So what I'm going to do here is I'm going to multiply these guys out. 3.1 times 16 times 9.81. Okay, plus 5.5 times 12 times 9.81. And I've got that, it's like 1134, something like that. And then I'm going to divide by 2 and divide by the sine of, let me check what mode I'm in. I am in degrees, okay. Answer divided by 2 divided by the sine of 52. Okay, here we go. 719.556. Right, and the tension, you don't have to say which way the tension is because tension is just tension, right? So that would be 720 newtons with a decimal point. Of course, along the cable, right, because it's a cable. So now let's figure out what the wall is in the x direction. So I just plug that in. I'm going to take this number here, right, and I'm going to plug it in there, right? Okay, so I've got the wall in the x direction minus 719.556. Keeps going, but hey, that's enough. Okay, times the cosine of 52 is 0. Okay, so now I can solve this. I'm just going to take that number and first store, and then I'm going to go times cos 52, and I get 443. Now the fact that it's positive means that it's in the direction that we assumed it was, right? We put a plus in front of there because we thought it was to the right. And the number we got is a positive number, of course, right? So we know that it's to the right, 443 newtons to the right. Okay, so now let's figure out what the wall is in the y direction. So we go wall in the y plus, and then I can take that number and plug it in here, right? 719.556 sine of 52 minus 16 times 9.81 minus 12 times 9.81 0. All right, here we go. So let's see, what do I do? I guess what I'm going to do is I'm going to multiply these guys out and put them on the right side. So 16 times 9.81 plus 12 times 9.81. 274, okay. And then, let's see, I guess I subtract this term, so minus times sine of 52. And I get negative 292. Okay. So the fact that I get negative for this thing, I guess that it was upward, right? That's what that is. That's an upward guess. But I just got a negative answer. So my wall in the y direction is negative 292.338. Strangely even number. Okay. 292.338. So the fact that it's negative means that it's down. All right, so let's write this in properly. 292 newtons down. Right. You could also say negative 292 newtons and put it in parentheses down. I do need you to say down. I need you to say to the right or the left. I need you to say down or up. Because I don't know necessarily what convention you use for your pluses and minuses. All right. Wow. If you get these right, by golly, you should really be proud. These are really tough problems. All right. Thank you for listening.